You're listening to FXomics, the home of personalised medicine with Dr. Mark Donoghue. If you're a healthcare practitioner and want to learn more about how to develop more targeted treatments for your patients using genetic testing, then Bioceuticals DNA Testing in Practice is for you. This 10-module professional development course, presented by Dr. Denise Furness, is designed to help you unlock your patient's health potential. You'll learn how to move away from the trial and error approach that so typically leads to patient dissatisfaction to a targeted clinical model defined by decision-making that distinguishes those patients most likely to benefit from a given treatment from those who will not. For more information on the DNA Testing in Practice 10-module program, visit the Bioceuticals website or contact your Bioceuticals sales representative. Welcome to FXomics with Dr. Mark Donoghue, your gateway to genetics, research and technology in the field of personalised medicine.
Hi, and a big welcome today to Carolyn Ledowsky, the founder of MTHFR Support Australia in my own local area in Sydney in downtown Neutral Bay. She's a naturopath, herbalist and nutritionist, Bachelor of Herbal Medicine, Naturopathy and Advanced Diploma in Naturopathy. Welcome this morning, Carolyn.
Thank you, Mark. It's great to be here.
I've got to ask you, it's MTHFR support, but it has become so much more than that, hasn't it? The MTHFR was the origins and then you've moved outwards. Tell me a bit about how you started and how it's progressed from that time.
That's a really good subject in itself.
Yeah.
My mentor at the time was actually Rachel Arthur, and we used to love delving into all the bloods and having a look at the finite, minute details and what it might suggest. And I kept seeing all the time, half of my patients would have this irregular red cell folate. And I kept thinking, what is this? And no one could tell me. Literally, it was just no one. I had interviews with doctors. I talked to professors. I rang the labs and said, why would this happen? And they said, well, it's a great thing. They're obviously eating a lot of leafy green veggies. And I knew that wasn't the case because the patients sitting in front of me were really sick, they were really ill, and they didn't have a particularly good diet. So it just didn't sit true to me. And that's what led me into the world of MTHFR. Right. Because I was after an answer to why some people would have a disturbed folate and others would not. And when I found that I saw the MTHFR gene, because I started testing with all my patients, I started to see this pattern that those with the MTHFR gene improved significantly when I actually took them off folic acid, got the folic acid out, and tried to regulate and optimize their methylfolate. And they improved 9 times out of 10. Right.
When was this?
This was in 2010, 11.
Right.
And so Ben Lynch at the time had just started posting about MTHFR, and so I became really obsessed. That then led me into the world of methylation, which then led me into all the other folate genes, the genes in the methionine cycle, the CBS and the transsulfuration, and I just started to then see that there were other genes outside MTHFR that were obviously just as relevant, but for me, the linchpin seemed to be the MTHFR. It seemed to be where a lot of the stuff started, and that's what led me into this other world of all the other genes.
It's a long journey then, isn't it? Because once you led down that path, it was a kind of similar feeling for me. People have mentioned MTHFR before then, and there was a pattern of, often the homozygous variants of that. Doctors paid attention to homocysteine, but that's all we paid attention to. And so if a person's homocysteine wasn't raised, we had no interest in this whole area. There is a whole other story behind that the reason doctors paid attention was people had heart attacks if their homocysteine went high and they were males, and they had heart attacks very young. And we doctors thought, well, you treat the homocysteine, people will get better. And it wasn't a homocysteine treatment. It was an entire Pandora's box that opened when you get into methylation.
Yes, exactly. And even today, Mark, there's so many doctors that still say, 10 years down the track from that, nearly 10 years, they're still saying, well, if homocysteine's not elevated, it's not relevant. And I think we just have to change the status quo and say, well, you know what? That's actually not right.
Yeah.
We know that methylation can be disturbed irrespective of an MTHFR polymorphism. And I think that's what I'm trying to get the word out with all practitioners, is that your environment mucks up methylation irrespective of any genetic SNPs. And so we have to be aware of that. Because, even as simple as a candida and an increase in formaldehyde and acetaldehyde, you can get disturbance in methylation quite significantly because it's inhibiting a major gene that is using folate, your methionine synthase. So we've so polluted, so many environmental toxins, and that's what my summit last year was about. How do we actually identify the key environmental factors that are stuffing up methylation, for want of a better word?
Yeah, it is that predisposition. You could look at the genes, look at the SNPs. You can know all about that, but if you don't know what puts the pressure on those, what makes them break or what makes them fail, missing the environment, nutrition, missing stress, missing all of those other factors, you may as well not know about the genes. The genes in isolation are not the answer here, are they?
No, they're not. And I think, for me, when I'm doing my case histories, the first sort of things I'm asking, particularly if I'm seeing MTHFR, is, what was mum doing when she was pregnant with you? Where did you live when you grew up? And I think these are really significant questions that we need to realise. It actually goes back to, fertilisation and what's happening with the genetics and methylation when mum and dad are conceiving. This is huge because methylation gets disturbed. And then if you see MTHFR on top of it and stress, you start to see these patterns emerge in family history.
It is involved in transgenerational changes too, isn't it? So the
Absolutely.
methylation, I think the dogma in medicine was always, sperm and ova will reset everything, the histones and the methylation, it's all cool, you start with a clean slate. But I think that's not the truth anymore, is it?
No, and in actual fact, what we're seeing is these epigenetic effects can be transgenerational, so 3-4 generations. So it's no longer what we do, it's what our mums and dads and our grandparents did that are still affecting our offspring. And I think that, it's scary on the one hand, but on the other, we know just how important now preconception is. And I have a huge preconception and fertility portion of my business because so many women with the MTHFR gene have terrible issues trying to conceive, whether it's multiple miscarriage or failed IVF. And I can testify again and again and again and again, you get that methylation right, it's absolutely fantastic and successful.
Yeah, I remember it wasn't all that long ago, a few years ago, one of the fertility clinics grudgingly came to this idea that, methylation is a contributor to the relative infertility. What was the answer? 5 milligrams of folic acid. That was it. There was no improvement in fertility. There's no subtlety to the medical understanding of this. And so that infertility is a far more subtle process. And then the pregnancy and the ongoing pregnancy and the health of the fetus and the ability to maintain progesterone and to see you through the first, 3 to 6 to 8 weeks of the pregnancy, they're all critical factors based on simple biochemistry and genetic risks. So how do you do that? You bring people in who've been to the highest paid, paid enormous amounts of money to get fertility advice where they never mention any of these. And you come back to a clinic like yours with simple changes of diet, methylation, gene expression, and people get pregnant. It seems like it should be in the mainstream of medicine, and it doesn't make it there.
You're so right, Mark. You're so right. And it's probably one of my greatest frustrations is that the standard protocol, as you said, in high-risk pregnancies, and usually there are all these people in the IVF clinics, is 5 milligrams of folic acid, exactly what you said. There was a paper released even last week to say that the 5 milligrams of folic acid is the wrong strategy.
Yeah.
And there's study after study showing that it decreases the methylation of sperm and eggs.
Yeah.
So why are we doing it? I mean, I can't believe that these IVF centres don't keep abreast with the research. It just seems crazy to me.
I think there's a simpler explanation that there are high-cost procedures that can be done, and this, if it emerged that a very low-cost, simple mindset was able to get fertility up in, say, 30 or 40% of the people that would otherwise go to the high-cost options, then you've got your answer, follow the money. Fertility is the Wild West of medicine right at the moment.
Oh, gee, Mark, it's sad to think that. But look, you know what? I work with a fertility specialist from Genea, and she sends me a lot of her MTHFR patients and has done for a couple of years. But she doesn't send them anymore because I never send them back because they fall pregnant. You know what I mean? So it's like, it's good. It's great that we're getting them pregnant, but I hate to think that you're right, but you may be to some degree.
I don't want to overstate it. I think people get into those high-tech things, but the business model of, $10,000 per cycle, if you found something that for $50 and a bit of education made as much of a difference as your $10,000 per cycle, you wouldn't be in business very long. And so I think that it is subtly and in the background, they disparage this as a trivial thing because to believe otherwise would be very difficult.
Yeah, you're probably right.
So can we go back a bit? There's two things that I want to understand. First one, just getting a bit of a 101 on what is methylation. Like the simple thing, I remember back in the 90s, one-carbon metabolism became a big thing and then it kind of faded. It wasn't called methylation, but shifting carbon and 3 hydrogens around sounds like trivial work that goes on all the time. Tell us just a little bit, what does methylation do? A couple of examples, pull them out of what body functions are controlled by methylation.
So what essentially methyl groups act as master regulatory switches, and that's why they're so important. So the ability to turn proteins on and off, turn enzymes on and off, we rely on methylation to do that, specifically our methyl groups. We have essential enzymes within our biochemistry that can only work with methyl donating their methyl, like SAMe donating its methyl group.
Right.
So, for example, phosphatidylcholine, which we need for cellular membrane health, we need for memory, we need for myelination of nerves. Most MTHFR patients will have problems with one of those three because phosphatidylcholine is not being made.
Right.
COMT, catechol-O-methyltransferase, is our key enzyme that gets rid of toxic estrogens. Again, people that have a lack of methylation have problems getting rid of their toxic estrogen. So they'll have this imbalance between estrogen and progesterone.
Right.
We have detoxification that is supported by methylation. We have creatine synthesis. So just having enough creatine for muscle development is essential. So these methyltransferases, which run key biochemical pathways, have to have this cute little methyl group attaching to activate them and make them work better. Just being able to get rid of dopamine, you need your metals. So it's profound.
It covers everywhere. I mean, it's also in an area that I deal with, the chronic post-viral people, almost universally poor methylators. Methylation is an important part of preventing viruses from hijacking DNA and just perpetuating themselves as well. So it does strike me that in almost every aspect of our biochemistry, a failure or a relative failure of methylation is setting you up for failure in some other area, or even just in the obvious areas, as you said, the catecholamines and the COMT and the specific areas that we kind of can pick up on testing. That's the tip of the iceberg. It percolates through the whole person, and you get whole person illnesses that are really difficult to disentangle.
And I'm so glad you said that, because that's exactly how I feel. Now, my gorgeous mentor, Rachel Arthur, will say to me, Carolyn, it's not all about methylation. But I actually think that it really is. It's the crux of why we have so many chronically ill patients, because our environment is disturbing it more and more and more. And if you look at take the idea about estrogens, we have so many xenoestrogens in our environment that it is putting that load on everybody, not just people with a COMT mutation.
Yeah. However, the mutation is the weak spot. I tend to think of a lot of these SNPs not as, people do make the mistake of thinking of them as if they are mutation. They are variants. The SNPs,
That's right.
The variation is a biological variation. It's like weak points that if you never put pressure on them, they don't break. But as soon as the pressure rises from environmental, nutritional, stress or other sources, these are the weak spots, and they express themselves as illness that we see as practitioners.
Yeah, and not all polymorphisms are bad either.
No.
We adapt as we go as well. So even changes to the wild type can be positive. They don't all have to be negative.
That's true. And so then we go one layer even further in with the epigenetics of the expression of these genes. So there are modifications of not just the variants of the SNPs and the genes themselves, but whether they're expressed or not expressed. Can you take us down that path a bit? You can have all the terrible genes that if they're never expressed, you seem to be able to go on with life. But if expression starts and you find those weak spots and they're tested, what do you do as a practitioner when you discover that, and how do you manage that? What testing do you do? What kind of advice can you give there?
What I will be always looking for in my first appointment, and I think the most important thing is looking at your timeline. So in your questioning, when you're talking about the patients, when did they fall ill, what was going on at the time, I think that gives you really good clues. And I think one of the best ones is looking at for example, the PON gene, which helps detoxify pesticides and organophosphates. And I look at people who have had lots of problems with multiple chemical sensitivities, and I'll say to them often, when did this all start? What was going on in your life at the time? And they'll invariably say, oh, well, I was a young kid and I was probably, in my primary school, and I'll say, and where did you live? Oh, we lived on a farm. Oh, really? Okay. And what sort of crops, were in that area? Oh, well, there was cotton crops beside it.
Yeah.
Okay. And was it aerial spray? Oh, yes, it was aerial spray. There were we used to see planes of kids going over. So straight away, you've now got your timeline. You've got where the susceptibility and the environment interacted.
Yeah.
And then you can say, right, and I love talking biochemistry with my patients, because if they can understand their susceptibility and they can understand where the environment intercepted with that, then the fixing of it, they become a lot more compliant because they understand why you're doing what you want to do.
Yeah.
And so I will use a combination of very detailed case history, bloods. So what are the bloods? And I think the bloods are really insightful, particularly if we can see elevated mean corpuscular volume and we know that perhaps B12 and folate are low. We can look at iron and thyroid and put all that case together and then say, okay, what are the symptoms? What other tests do I need to give me more information? And sometimes your testing will be to improve compliance with the patient, to help them understand where they are. So, for example, organic acids, in that case I gave with PON1, can often pick up an elevated oxalic acid. And so you can say to your patient what our next step is to take oxalates out of the diet, improve the working of this PON1 gene to make sure that you are clearing these toxins, and we support, obviously, phase 2 to go with that. So it depends. The testing will obviously depend on what you've discovered in that original appointment. And sometimes, if histamine is elevated, you want to be looking at gut function. And is there some sort of dysbiotic bacteria that's potentially creating an excess of histamine that they haven't got the ability to break down? Or they're taking some medication that's affecting the DAO enzyme, which again is affecting histamine breakdown.
Right.
So that this fact-finding mission that you're doing at your first appointment is really giving you a very clear path, I believe, in what area you need to test.
Yeah, I absolutely support you there. The history is critical. Lots of doctors, lots of people think, genetics and this testing is the shortcut to taking a history. It's meaningless without a history. You can have any gene you like, but if there is no history that fits the timeline, you don't have a real reason to go and pursue that as your primary outcome and the cause of your illness. So that work, there's no way around asking the questions, getting the timeline, looking at the person. And it is what so many of us forget, that technology kind of replaces the clinical history and that timeline. It's a great way of getting to the bottom of it. One other example, the kids that are put on antibiotics, they're for all the way through their youth, or they're on acne for antibiotics, or they're on Roaccutane, which is isotretinoin for acne management later, that there is a clear, before this point I was well, after this point at some timeline, things started to fall apart. And that's the Sherlock Holmes work, isn't it?
Oh, absolutely. That's what I say to my practitioners in my mentoring groups. You need to almost be a medical detective.
Yeah.
Yes, if you're seeing a variant report and you can look at their susceptibility, that can actually give you good clues as to where you need to go down as far as your questioning goes. So if you're seeing a COMT homozygous, you may well ask if there's any family history of estrogen metabolism issues, fibroids, fibrocystic breast, endometriosis, breast cancer, prostate cancer. And so it can give you clues, but it can't be, I agree with you, it can't be, you have this, and this is one of the things that annoys me, is that people go into health food shops or wherever it happens to be, and they say, you're homozygous for MTHFR, you need buckets of methylfolate.
Yeah.
It's not the case.
That is the other one of my concerns, is that these days people bring in an entire genetic 140-page document and slam it on the desk. We've taken to scanning it, but the question that they will often start a consultation with is, I'm sick and these are my genes, tell me how to fix it. As if they are somehow separated from their history, from the events that they have been through. And without knowing the stressors, without knowing how and where those genes may fail, it's great to have that information, but overload of information can sometimes make us blind to the bloody obvious.
Yeah, and I think, Mark, one of the things that I think practitioners do need to understand is that this is the way we are going. This is the direction that we as practitioners, whether we like it or not, this is where we're going. And I think it's because the patients, and particularly those that are chronically ill, are not getting much support from the medical model. Yeah. We do acute care particularly well, but we're floundering in people who have chronic health conditions. And back for me in 2010, this was consumer-driven. It was not practitioner-driven. It was consumer-driven. And I knew, literally within a week of rechanging and redirecting my business to MTHFR Support, which my husband thought I'd lost my mind, he seriously said, you have got to be kidding. This is too niche. Absolutely no one's going to know what the heck you're talking about. But literally within 3 months, my business had increased by 300%. And it's because people were looking for things outside the norm to try and explain why they might be so chronically ill.
Yeah.
And look, I don't mind at all people throwing that report on my desk, because for me, I feel like I'm delighted that they're interested enough in their health to want to do it. And I absolutely love their questions, and I love educating them to understand how their body and their history intertwines with their genetics.
So many of them have actually got that help from you being there with MTHFR Support Australia. It has a mission also of education of the public so that the awareness is there to ask the right questions, rather than just to say, I have a gene that may or may not be fixable, please, what do I do for it? The subtleties and the awareness that diet, nutrition, lifestyle, stress reduction, that doesn't come by knowing the genes. That comes by knowing practitioners who know how to work with those genes and how to escape from their destiny.
Yes. And you said before about expression, and I do think stress, just whether it be physical stress or mental stress, is really one of our key triggers, because methylation is disturbed hugely because we use more methyl groups in our stress response.
Right.
And so, just asking people about their stress and when things happened and when they became ill, you'll usually find that there's some sort of stressor that happened at the time. And if then they have, say, a homozygous MTHFR polymorphism, then their ability to cope with that stress is worse than the person beside them, because they just don't have what it takes to create enough metals to support the stress response.
Yes.
And, I often say adrenal fatigue, there's no such thing, which I think is very controversial in a way. But what I've seen, Mark, which is quite amazing, is if someone comes in and you would classically look at them and go, you know what, you would be the typical adrenal fatigue person. But if I get their methylation right and they've got the right amount of nutrients and the right amount of methylfolate, literally overnight they'll come back in and go, what stress? Because their ability to cope with stress has just been completely eroded. They don't have a problem anymore. They cope with stress like anyone else would. So it made me think, well, maybe that's all adrenal fatigue is this inability to control the stress response because of a lack of methylation.
Maybe the mainstream is starting to join you in that. But I think the concept of adrenal stress, there's clearly the medical, the adrenals fail and you get Addison's disease. There's clearly disease states of the adrenals. But the adrenals are the classic adaptive organism. They will close down at certain times. They go back to a hibernating state relatively regularly when they're unable to do anything else. And so adrenals, when they fail gracefully. We interpret it as adrenal stress, but it in fact is usually a metabolic stress. And the adrenals are choosing the best path they can possibly work out to get through that, assuming it's a winter and 6 months' time will be fine. And that 6 months, that winter never ends and they never get back to fine. And people stay in that chronic state of depressed health where every stressor now plays out dramatically on their health.
Yes, exactly.
It's a great area because I agree with you. Managing their methylation at that point does allow them to resume function. I mean, we doctors have a favourite thing of jabbing people with high-dose vitamin B12. There's about 20 or 30% of people who spring back to life with nothing more than a B12 jab, and we never understood why. It was done for the last 50 years. And I think we're getting some concepts that it's not for everybody, but for the right person, you kind of give a push start to the adrenals, and they go, oh, I've never noticed that before, and they come back to life in that same way.
And I pay very close attention to the B12 SNPs. Because I really do believe there's significant information we can gain from that. Yeah. And I'm actually about to do a big presentation on B12 because for me, it's so important. And my father-in-law was a doctor and his standard protocol was, anyone over the age of 50, he gave them a B12 shot, as you said. And I'm going back sort of 50 years. And he was considered to be, quite ahead of his time. But it is so important. I think B12 is one of our key nutrients that we're just missing. And we go off the bloods and we go off, testing, but it's the one place I really think we need to be going off our signs and symptoms.
I think you're right. I mean, one thing that is true is if livers are a major source of B12 storage, when there's any inflammatory gut issues and the liver is under load, the B12 initially gets liberated from the liver and you usually have high B12 levels that is unusable by the tissue. And so if you just simply measure the B12, you think, oh, that's fine. How could anyone need anything? Without asking the question, now, why would it be that high in a perfectly normal, healthy person? So I think, you can misread red cell folate, as you said before. We can misread a whole lot of those nutrients because we're watching the blood and saying that's okay and that's not, without a deep understanding of biochemistry.
Yes, and I've got some patients that have been diagnosed with MS who I look at their genetic susceptibility to having low B12.
Yes.
And when I really superload the B12, their MS symptoms pretty well disappear in most cases.
Isn't it fascinating?
Yeah. And I really think in some instances where you're seeing these genetic susceptibilities to B12 and they've been diagnosed with, conditions like MS and etc., we can make significant difference. And I think a lot of the time, one of my patients said, well, I question whether I have MS now because my symptoms have, 80% gone. But I think the 20% residual was, I guess a long-term B12 deficiency and they've got, irreversible neurological damage.
Yeah.
So I think it's interesting and I love the insight that we can get by looking at the research, what it's telling us. And what I also love, Mark, is that because this is such an emerging science, every day we're seeing patterns of SNPs that are having effect on disease states. We're seeing different genes being identified, different combinations of genes being identified. And I find it really exciting. It just keeps me up and going every day.
Carolyn, it is exciting, but it's also confusing. I mean, you're living in that area, living and breathing it, and I think you've got the best grasp of it. But for the average practitioner, we sit there thinking, we know there's something wrong. Every week there's another 40 units of information that we struggle to digest. How is it even possible? How do you stitch the diverse combinations? How do you get all that, what for me is relatively incomprehensible? How do you turn it into advice for the person in front of you? What's your technique of grabbing the data, the genetics, the SNPs, the organic acids? How do you bring that together for the person in front of you without just going into overload and confusion?
So the patient or the practitioner?
I'm talking for us as practitioners. Your depth of involvement in this gives you special powers, like superpowers. But for those of us who are kind of dealing with, say, the chronic fatiguers, the autistic children, that we get presentations and there are so many possibilities in the genetics that personalised medicine is sometimes very threatening to us. How do we change our mindset? And how do we incorporate what is rapidly changing and vast information from genetics, from SNPs? How do we turn that into sensible advice for a patient without becoming just overwhelmed and saying, I will pay no attention to it at all?
Yeah, that's a really good question. I actually set up a practitioner membership group. So this is what we go through on a monthly basis. Right. We meet on Facebook twice a month, so that we can actually start talking about it and doing. So I do case history. And basically what I say to the practitioner is there are very simple things that you need to do. First of all, you do your timeline. You do a really good case history, and then you put the basic supporting nutrients in while you discover what you need to do. So if you are looking at, let's face it, probably the most important thing I'd say now is liver detoxification.
Right. Because
our livers are inundated every second of every day. So I would say start with the basics. And we know that there's really good combinations of genes that we can start to look at that gives us a clue as to where we need to push our patient in the direction with nutritional advice, dietary advice, and lifestyle advice. So, for example, if you see combinations of CYP1B1 and COMT, then you're going to definitely improve estrogen metabolism as one of your first steps, improve glucuronidation, improve their ability to get rid of toxic estrogens, and from a lifestyle point of view, counsel them in getting rid of xenoestrogens out of their environment, cutting out any endocrine disrupting hormones in personal care products. So it doesn't need to be complicated, Mark. I think the biggest issue for practitioners when they're new to this is you've got, even if you look at any genetic report, there's a multitude of stuff.
Yeah.
And so for me, B12, I think, is really significant, and I definitely look at that first, because without B12, pretty well methylation shuts down. So I look at, are they vegetarians? Are they vegans? Have they got problems with low hydrochloric acid? So I will evaluate those first. And then you just look at their timeline. As you said before, where's their susceptibility? That's what you should be concentrating on first. Plugging up that pothole of susceptibility and undoing what many years of, I guess, this susceptibility has potentially caused in the way of either multiple chemical sensitivity or estrogen metabolism. So it doesn't need to be complicated. I do get why it is overwhelming, but I think the danger is we can be too clinical in presentations, and what I try and do is always give a clinical application. If you see this, I want you to be thinking about this.
Right.
And that's what we need to be helping practitioners with, really getting the initial connections, the initial important susceptibilities, and then what do we do in clinic and how do we explain that to our patients? Because I'm very basic with how I explain this to my patients. I basically say, right, you've got some genetics here, and from the timeline, I can see that this all started when you were living on the farm. So I suspect what was happening at that time is that your ability to get rid of those pesticides that you're exposed to has put additional pressure on that liver to cope. You've also got a glutathione deletion gene, which means this PON1 piggybacks with your glutathione. So you have a double whammy issue. So our first port of call has got to be to improve that.
Okay.
And then they go, oh, okay, that's great. And then the next appointment, we'll talk about something else. But usually at that first appointment, it's giving them a bit of a background, giving them a diet and lifestyle that I want them to follow, and then just start putting in key nutrients. So if B12 is low, I'll start putting in B12. And then you can progress.
Do you look just for clinical improvement, or do you use, say, organic acids? Do you use other biomarkers to assess how a particular intervention is going, or is it based on...
Oh, definitely.
Okay, so what do you use?
So I pretty well always do an organic acids. I find that is a really lovely place to start because you're looking at bacterial markers. I really want to see whether yeast is a problem, because if arabinose is elevated, then I'm a bit suspicious that methionine synthase may be having a problem.
Mm-hmm.
I also look at, you then get glutathione status. A lot of the time you're getting MMA, you're getting all your key nutrients that are really important for it, at least initially, because if you've got a lot of nutritional deficiencies, you've got to address those first, haven't you? And that is probably your most important thing. Balance what is out of whack. And then, because if you've got no zinc and no hydrochloric acid, you're obviously going to have a problem. So and if you've got yeast, you've got to address it. We've always talked about gut, but the more I get into methylation, the more I understand that disturbances in bacteria are going to have profound effects on methylation, and whether it's a histamine problem or an oxalate problem or a yeast problem, it doesn't matter. We've still got to address it. So organic acids is one of my favourite, love doing it. I will then do estrogen metabolism if I'm seeing issues with COMT and CYP1B1, and I know there's a family history of estrogen dominant conditions. And if I need to, I'll do gut. If I'll do a stool test if I think that I need to add that on. But I pretty well would start with an organic acid. If money was an issue, that'd be my go-to.
And so the urinary sterols are a part of your routine investigation, or only when you've got that specific set of genetic predispositions? Do you go down the sterol pathway all the time?
No, I don't. If they don't have a family history of estrogen dominance, if they don't have their own history of estrogen dominance, and if I see CYP1B1 and or glucuronidation genes and COMT, I'm going to do it. Yes, I am. Because even though they may not have symptoms, if they've got an incredibly elevated 4-hydroxy, I need to deal with that.
Yeah. You have the job of preventing their future health problems, not just the current ones, don't you?
Absolutely. And Mark, my family history is really interesting because I ended up with endometriosis at 22, which is quite young. And I knew that with my girls, I didn't want them to go there. And so for me, being able to give them things, as teenagers, indole-frees and, calcium D-glucarate and really help that liver get rid of those has been fantastic, because I'm sure if I hadn't have done it, they would have ended up the same place as me. And I find this incredibly powerful. It
is, to be able to use your own history, a parent informing the entire family history, or a child sometimes. Children are often the place where the genetics become apparent, and you can make sense of other family members and even relatively distant members. It's a very powerful technique beyond the individual involved as well.
Absolutely. Yeah, definitely.
It's the tragic thing is often, the mother and the grandmother's breast cancers, no doctor thinks that we can do anything about it, but the understanding of the predispositions, not just BRCA1, BRCA2, but the understanding of these dispositions of the toxic estrogens and what can be done about it. I find one of the tragedies of medicine, we wait for the cancer and then do something that should have been done 30 years before, as you've done with your children.
And Mark, I also, I think the whole Angelina Jolie thing was just so unnecessary, because what it basically said to everybody is if you've got the BRCA gene, you're going to end up with ovarian cancer or breast cancer. And it's not right. As you know, and we've said many times in this interview, the environment plays such a huge part.
Yep.
And so just because your mother or your grandmother had breast cancer, it does not mean that you will get it.
Yeah.
It means you might have a susceptibility, and so we can do really powerful stuff to prevent that. And I agree with you. I think it's a shame that every GP and every specialist out there doesn't understand that and go, okay, we're going to make sure you don't end up that way.
One big question, I've discovered this, doctors always come late to the party that the naturopaths knew for decades or even 100 years before. But it does strike me that the gut, the microbiome, the liver, that kind of unit of function has been so disregarded by medicine and is so critical to whether our genes are expressed and in what way and how we detoxify. To me, it almost seems routine that if the gut is managed, 50% of predicted risk probably disappears with nothing more than really, really good gut management. Do you have a similar experience, or is that a little bit on the soft side?
No, I really do agree with you. I mean, think about even stress. Stress really affects gut function because you're decreasing hydrochloric acid in the first point. And you're disturbing all your neurotransmitters, your serotonin, cortisol and everything else is affecting gut function. And we know that there's such a huge interaction between gut and brain. I think the biggest issue we've got is parents not understanding a lot of the time that massive doses of antibiotics regularly is obviously having a profound impact on everybody's gut. Yeah. But even things like, now it's regulation in a lot of schools that you have to use that stupid-looking antibacterial wash before you walk in. I mean, we're not allowing our kids to play, so the diversity of the gut is being affected.
Yes.
And I think it's a multitude of things that are really affecting gut function. And we all know that if gut is good, the chances of other things being then affected are much less.
Yeah, you bring your candida, you bring other things back under control, the Clostridium settle down, and a lot of the signalling seems to be settled, a lot of the inflammation on the gut and the gut permeability. If you get control of those, they seem very powerful moderators of the genetic predispositions that we may carry.
Incredibly. And we, with all the work on the microbiome and, medicine now discovering how important it is, you're right, it's probably 100 years after most naturopaths and nutritionists, realised it, but at least they're getting there.
Yes.
And I think that it's only going to open up to the average GP and doctors out there that it is important, and we need to be thinking about antibiotic use and antibacterial use, I guess, is really important.
We have 150 years of making every microbe our enemy, only to find out that the vast, vast, vast majority were the things separating us from ill health the whole time. So getting a new relationship with our bugs seems to be one thing, and it's happening slowly in medicine, but it at least is happening. On that, where do you see the future? Like, you've been at this for around about the last 8 years. Is there a direction emerging? Do you see anything of doctors awakening to what is going on with, say, methylation, gut, gene expression? Is this still a hard slog? Do you see the future as opening up a little bit where medicine, genetics, predispositions actually talk the same language?
Right now, it's a very hard slog.
Is it?
And I have a lot of my patients that end up saying, look, you know what, this discussion is just too hard. I'm getting fought on every single front, and I'm over it. So I'm just not going to say anything. And what we actually find is that they are pretty well healthy going forward, and then they just go to the doctor, if they need something.
Yeah.
So essentially, no, I don't feel like the medical world is coming to the party at all. I think you've definitely got your researchers that are saying, hey, the genetic susceptibility is a real thing and we need to be taking note of it. But I think the average medical professional is saying, oh, this is all hoo-ha, and really we can't do anything about it.
Yeah, we have to break that habit, don't we?
We do. And I think where we're going, though, and one of the reasons why, integrative doctors are so busy and so flat out, and I'm really pleased that the integrative doctors are really excited about what I'm teaching. And I've just come back from Chicago to teach 150 doctors in the US on how to get involved with methylation. And I'll tell you what, the excitement in the room was so good. They were so interested, they were so into it, and they just want to learn this stuff because I think they can really see that this is going to make huge inroads into their practice and how they improve the health of their patients. But outside the integrative world, it's not happening. So where will we be in 10 years? I think in 10 years' time, every patient will be at some point coming in and saying, here are my genes, I'm really not well, what do I need to do? And I think the medical world will come into this sphere because they'll have to, because they will be completely left behind if they don't.
There's a lot of work also to do on the computing side of that. When doctors love to see results on a piece of paper and treat diseases where there's big asterisks. And we were over at Genome One looking at when whole of genome testing becomes a $200 test where you can actually nominate every single gene and variant in every SNP. then what you next need is the computing power to say, well, it's not just the things that cause disease, it's those predispositions. How do you put the greys together to say what's turning black and what's turning white? And that's a lot of technical work. I suspect the science and the biology have to go hand in hand, and the doctors often are a decade behind or 2 decades behind for when the solution is fixed and a piece of paper comes out says, consider the following. Can you see us being there in 10 years' time where a genetic report, a summarised genetic report, changes the way a doctor views their job? You know, I can prevent something, I can help this person, I don't have to give a drug to try and change them to some way that I want them to be.
Yes, I do actually.
You do? I
do feel like that's where we're going. Again, it's going to take interpretation to some degree, but I do think it will be, here's this person's genetic susceptibility, I've plugged in their family history,
yes.
And therefore here is the key genes that I really need to keep my eye on, and perhaps here's the nutrients that support it. That's where I think it would go, because then it makes it more relevant to the average GP.
Yeah, it's clinically relevant, it fits with what we understand, and it gives us new tools to do good rather than wait for harm to happen and then try and patch it up at the end. I think there is a turning point, and I'm hoping that it's not 10 years. I want to thank you very much for the talk and to say congratulations, the bringing of awareness, not just in the area of methylation, but in the area of susceptibilities. You're doing a marvellous job. You turn up everywhere. Everybody has heard about you. And for something that started only 8 years ago, that is magic all by itself. So I honour you, Ben Lynch, others, Elizabeth. There's a group that are taking this forward, and you will be attacked. But I honour you for the work that you're doing. It's necessary, and we have to change that direction. So thank you.
Thank you, Mark. It's been great talking to you. I just love it. And as you can probably tell, I get so excited about it because it's just such a powerful tool that we've got to be able to put all this together and see really amazing clinical changes. There's nothing more exciting as a practitioner to have someone that's been sick for 30 or 40 years to be able to see a difference in a few months is not only so exciting for the patient, but also, I think, for the practitioner.
It's so rewarding for the practitioner. It makes me feel that our medical education, not wasted, we're good at fixing diseases, as you said, patching people up, but it's an unsatisfying profession when you know we should have done better. And what you've told us today, I think, is part of that story. How do we learn the tools of doing better, preserving and maintaining health and not allowing these diseases to progress? Carolyn, thank you so much for joining us on FXomics today.
Thank you.
This podcast is brought to you by Bioceuticals Clinical Services, bridging the gap between modern genetics and nutrition.